For today's video, we will answer a math challenge given by one of our followers from India. And the question goes like this. What is the value of AB plus BC plus AC given these three equations? A squared plus B squared plus AB equals 11 squared. B squared plus C squared plus BC equals 13 squared. And C squared plus A squared plus AC equals 20 squared, wherein A, B, and C are both positive real numbers. Then what is the value of this expression, AB plus BC plus AC? Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright. So our goal here is to solve for the value of AB plus BC plus AC given these three equations wherein A, B, and C are both positive real numbers. Alright, now since A, B, and C are all positive real numbers, so I have here two suggestions. So one suggested solution must be using algebra, of course, because this given is a lot of variables and numbers, so it is algebra in nature, so we can use, of course, algebra. And my second suggested solution, this is my favorite, we can convert this to geometry. Alright, so using algebra, it takes me a lot of time to answer this kind of question, so let's eliminate the case of solving this using algebra. But instead, I will show you the solution to this one using geometry. Alright, now the question is, what concept in geometry do we need to use to answer this kind of question? So we cannot use Pythagorean theorem because we know we have A squared plus B squared and C squared, we have three square numbers, but we have an extra expression AB. So Pythagorean theorem is not that helpful to this kind of situation. But take note, aside from Pythagorean theorem, we have also what we call the cosine law. Now, cosine law states that if we have this kind of triangle, so we have C squared equals A squared plus B squared minus 2AB multiplied by the cosine of angle C. Now, why is this important? Now take note, we have here C, if we let C equals 11, so we have 11 squared right here. We have 11 squared. We have A squared plus B squared. This is also visible in this equation. And we get an extra AB right over here. And that is what we want. Alright? So using this cosine law, it tells us that this negative 2, this factor negative 2 times cosine of C must be equal to 1. And since we will use this in this three equation, so why not we let this angle, angle C, angle A, angle B, and let's call this as theta. Alright, so negative 2 times cosine of theta must be equal to 1. So this is the condition that we need for us to use the cosine law in this kind of question. So now let's find what is this angle theta. So let's solve this. First, let's divide both sides by negative 2. So cosine of theta equals negative 1/2. Next, let's take the arc cosine on both sides. So theta equals arc cosine of negative 1/2. And arc cosine of negative 1/2, sure enough, we get a value of 120 degrees. So this angle right here, or the angle that we want, must be equal to 120 degrees. So, using this condition, we can now change this algebraic problem into geometry problem. So let's start. First, let's have some lengths like this, and let's call this angle 120 degrees to apply the cosine law. Let's call this segment A and this segment B, and this side right here must be equal to 11. Now, using this triangle, this is, if we use cosine law, this is exactly what we have. This is A squared plus B squared plus AB equals 11 squared. So using cosine law. Alright, now let's continue. From this point, let's make another segment right over here, and let's call this a C. And then this point and this point, let's connect this one, and let's have again 120 degrees, and we have 13 this side. Now, using cosine law on this triangle, we get the second equation. So we have b squared plus c squared plus bc equals 13 squared. And if we connect this point to this point, and we call this as 20, this triangle right here, if we use cosine law, we get the third equation, c squared plus ac equals 20 squared. So, this algebraic question can be converted into this geometric problem. So again, let's focus on this figure. Now, the main question is, again, what is the value of AB plus BC plus AC? But this is now easy to solve. Now, what we're going to do here is to get the area of this triangle. And in order to get the area of this triangle using its side, we will use the Heron's formula. Now, using Heron's formula, we have A, or the area of this triangle, equals square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C, wherein S is the semi-perimeter. So we can now get the semi-perimeter because all of this side length of the triangle are given. So let's use this. So S, or the semi-perimeter, must be equal to 20 plus 11 plus 13 divided by 2. Now 20 plus 11 plus 13, this will give us 44. And 44 divided by 2, this will give us 22. So this is our semi-perimeter. So we can now get the area using the Heron's formula. If we do that, we get something like the area of this triangle must be equal to the square root of 22, this is S, multiplied by 22 minus 20, multiplied by 22 minus 11, multiplied by 22 minus 13. Now let's solve for the area of this triangle. Now 22 minus 20, this is just 2. 22 minus 11, this is just 11. 22 minus 13, this is just 9. Alright, next, notice that 2 times 11 is 22 also. So 22 times 22 is just 22 squared. And this 9, take note, we have here 3 squared. And the square root of 22 squared times 3 squared is simply equal to 22 times 3. And 22 times 3 will give us 66. And that is the area of this triangle. Now, how do we use the area to solve for the value of AB plus BC plus AC? Now, the area of this big triangle must be equal to 66, we know that. And if we add the area of this triangle plus the area of this triangle plus the area of the third triangle, this must be equal to 66 also. Alright? Now, to find the area of those triangles, we will use this concept. So the area of this triangle is equal to 1/2 times AB, this side, multiplied by sine of included angle, C. So we know our included angle here is 120 degrees, and we have the side A and C. So, using this concept, we can say that the area of this triangle, we know this is 66, so 66 must be equal to 1/2 times AB times sine 20, which is our first triangle, here it is, plus 1/2 times BC times sine 20, this is our second triangle, the area of our second triangle, plus the area of our third triangle, 1/2 times AC plus sine 20. This is our third triangle. And we know this is equal to 66, which is the area of the big triangle. Alright, now let's simplify this. Sine of 120 degrees, we all know that this is equal to square root of 3 divided by 2. Therefore, all of this sine 120 must be equal to square root of 3 over 2. Next, let's multiply square root of 3 over 2 and 1/2. This will give us square root of 3 all over 4. Now, all of this must be equal to square root of 3 over 4, of course. Now, let's focus on this equation. Because if we factor out square root of 3 over 4, we get something like square root of 3 over 4 multiply by AB plus BC plus AC, which is what we want to find. Alright, so to find the value of AB plus BC plus AC, let's multiply both sides by 4 first. And then let's divide both sides by square root of 3. Now, let's rationalize this expression on the left-hand side of our equation. So, let's multiply this by square root of 3 over square root of 3. Next, multiplying this, the denominator becomes square root of 9 or simply equal to 3. Now, 66 divided by 3, this will give us 22. And 4 multiplied by 22 square root of 3, this will give us 88 square root of 3. And that is the numerical value of AB plus BC plus AC. Now, your question is this correct? Why do we use geometry? Because A, B, and C, we know we have positive real numbers. And A, B, and C are side length. Therefore, A, B, and C must be a positive real number. Therefore, our answer to this question literally must be equal to 88 multiplied by the square root of 3. And now, if you solve this using algebra, just comment your solution in the comment section down below. So, I love to read your solution. Alright, and as always, we are done.